Good morning, seventh graders. Happy Monday. We're going to continue with our textbook. And today, instead of talking about algebra, we're actually going to move on to a little bit of geometry. You guys, this might be review for the majority of you. We're going to be talking about angle classification today. So make sure that you have a notebook, piece of paper in front of you, a pencil, a glass of water. Pause the video now if you need to go do so. Make sure you also have our textbook page up. And that is located on Google Classroom. It's 8.1 angle classification. So without further ado, let's just get right into it. Mark wants to paint his bedroom door. The shapes on the door remind him of geometry. He wants to use a ruler to measure the actual lengths of the sides and a protractor to measure the angles. Remember, rulers measure length, protractors, I'm sure you guys have used those before, measure angles. He notices the same angle repeating over and over again. What type of angle is formed by a corner of a door? In this concept, we're going to learn how to classify angle. So here's the deal, guys. You guys need to make sure that we have our definitions written down. So on your notebook piece of paper, I'm just going to write down what definitions you need to have. So our first one is an angle. An angle. And no, not my last name. An angle as in a geometric term. An angle is the space created between two lines, or a segment, line segments, or rays connected at a common point. So looking here at this example, we're going to have angle A, right? This is angle A. Right here, where this point is, the distance between those two lines, that's called an angle, okay? Angles can be represented by using a symbol. Here's the symbol for an angle. So right here, you have that a little angle, and then just A. That's a symbol, right? So go ahead, make sure that you have this definition down. Angle is the space created between two lines, line segments, or rays connected at a common point. And then let's move on to our second definition. Angles are measured in degrees. That's our second term, degrees. Degrees measure the distance between two lines. This symbol right here, if we have x degrees, this symbol right here, that represents the degrees, okay? So what I just highlighted right there, that is what represents degrees. The number of degrees tells how open or closed the angle is. So if we have an angle right here, the measurement that would go right here is our degrees. This should be review for a lot of you. The smaller the number of degrees, the smaller or more closed the angle is. Angles are classified by their size, my friends. Angles sizes can range from 0 degrees to 360 degrees to complete a circle. Here's a diagram that shows some measurement. So if we have a complete circle, it is 360 degrees. However, looking at this one right here, if we have 3/4 of a circle, that makes 270 degrees. And if we just have a straight line, that would represent 180 degrees. As you can see, the angle of 360 degrees makes it a complete circle, right? So if I were to say, do a 360, you would just turn around in one and you would start where you would end where you started. An angle of 270 degrees is 3/4 of a circle, and an angle of 180 degrees is half of a circle. A 180 degree angle is a straight line. Angles that measure between 0 degrees and 180 degrees are classified as acute, right, obtuse, or straight. So that brings us to our next point here, an acute angle. An acute angle, my friends, measures less than 90 degrees. An obtuse angle is our next point. An obtuse angle has a measure greater than 90 degrees, but less than 180 degrees. See if it loads. Sorry, I'm making this video at 8 in the morning. My Chromebook just likes to work a little slow. So we can see some examples right here. All three of these represent angles, acute angles, right? 45 degrees, 20 degrees, and 65 degrees. Right here, these all represent obtuse angles because they are over 90 degrees. 145 degrees, 95 degrees, and 170 degrees. An angle that measures at 91 degrees would be considered obtuse, my friends. Most angles in the 0 and 180 degree range are either acute or obtuse. However, there are two special angles with exact measurement. So that brings us to our next couple points here, my friends. We have right triangles. Right triangles measure exactly 90 degrees. Right angles, not triangles. Sorry, I'm getting ahead of myself and getting into next week's lesson. A right angle measures exactly 90 degrees. Right angles are one of the most... Remember, I'm saying right angles, not right triangles. I'm getting ahead of myself. Angles. Right angles measure exactly 90 degrees. Right angles are one of the most important concepts you need to know about geometry. Right angles are found in squares, rectangles, and triangles. They're everywhere in the real world too. My Chromebook screen has a right angle on it. So here's a couple examples of right angles. Rectangles have 4 right angles. So do squares. Right triangles only have one right angle. Notice that a small box is used when an angle is a right angle. So we have this right here, this little symbol. This, if you're looking at a triangle or a square, if you see that, that means that it is a right angle. So you can see right here on the triangle where it has 90 degrees and it has the little box, that represents that is a right angle. There are many places in the real world where we can see acute, obtuse, or right angles. Here are some examples. So we have them right there. If you look at each of these pictures, you can see right angles clearly. Also notice that the wires of the bridge stretch to create acute angles on each side of the center beam. So if you look right here, you can see acute angles of the strings going down from the center beam. Those are less than 90 degrees. The other special angle is called a straight angle. A straight angle forms a line and measures exactly 180 degrees. So let's look at this example right here. If it's a straight line, my friends, it is 180 degrees. Now let's try classifying some of these angles. But before we do that, I want to make sure that you guys have all of our terms written down. So make sure that you have angle, degrees, acute angle, obtuse angle, right angle, and straight angle. Make sure that you have all of those terms written down. Pause the video. Make sure that you do that here. Now, let's look at some examples here. Right on my screen, I have angle 1. Now, we need to classify this. Is this a acute angle, an obtuse angle, a right angle, or a straight angle? Acute angles have to be less than 100 or less than 90 degrees. So a right angle, we know, looks like this, right? It's a quarter of basically a circle. Is that bigger than a quarter of a circle? It sure is. So this is bigger than 90 degrees. What angle is bigger than 90 degrees? Look at your notes. It would be an obtuse triangle. Nice job. So let's look right here. Is this greater than a right angle? It sure is. Is it obtuse? It wouldn't be because it's a straight line, right? So what kind of line or what kind of angle would this be? It would be a straight angle. Nice job. Now let's look over here at angle 3. Right here, is this greater or less than 90 degrees? If an angle is less than 90 degrees, What type of angle is it? It would be an acute angle. Nice job, my friends. And the last one right here, example 4. Is this greater than or equal to a right angle? Right here. It is equal to, it shows a quarter of a circle, so that would be a right angle. Although it doesn't have the exact box, you can tell because it's a quarter of a circle. So my friends, this is where you are ending today. On tomorrow, we'll go through the examples. Make sure that you have your definitions written down, and we will rock and roll tomorrow, okay? Pause the video here, and then we'll pick up right here. All right, kiddos, welcome back. Happy Tuesday. Let's review our angles, our definitions from yesterday. We have an angle. An angle is the vertex between two straight lines, and it's the kind of the crossing point. Degrees is the measure of whatever the angle is. So what is the width between those two lines in degrees? We have an acute angle. Acute angles are angles that are less than 90 degrees. Obtuse angles are more than 90 degrees. We have right angles, which are exactly 90 degrees. And we have straight angles, which are actually straight lines at 180 degrees. So today what we're going to do is we're going to go through, do the examples. You guys are going to take a little quiz, and then you guys are going to be done for the day. Sound good? All right, let's rock and roll here. Earlier, we were given a problem about Mark and his bedroom door. He notices the same angle on multiple points on the door. What type of angle is formed by the corner of a door? So if you look at the corner of your door right now, what type of angle is that? So if I'm going to clear this page, actually, you should have these definitions down. So if I'm making a door, right, here's my door. You have the knob. What kind of type of angle is right here? It's a right angle, right? Look at your door right now. You should see, unless you have a curved door, you should see 4 right angles on your door. The 4 corners of your door. All right, so example 1, we found out that Mark was looking at a bunch of right angles on his door. Let's look at example 2. True or false? An acute angle can also be a right triangle. So we know an acute angle has to be less than 90 degrees. Now, we have to remember that angles measuring exactly 90 degrees are special angles. So, an acute triangle has to be less than 90 degrees. A right triangle is exactly 90 degrees. Because an acute angle has to be less than, it cannot be a right triangle because it's less than. It's not less than and equal to, it's just less than, right? So if we were following this example here, we would have an acute angle is less than 90 degrees. It's not less than or equal to. It's not. It's just less than. Okay? So let's go on to example 3. Example 3, my friends. An angle greater than 90 degrees but less than 180 degrees. So it's greater than 90 degrees and it's less than 180 degrees. So if it's not exactly 90 degrees, it's not a right triangle. If it's not 180 degrees, it's not a straight angle. So what do we call angles that are greater than 90 degrees but less than 180 degrees? We call them obtuse angles. Nice job, my friends. Example 4. We have an angle that measures 15 degrees. So 15 degrees. Is that 90 degrees? Is 15 degrees equal to 90 degrees? Nope. So we know it's not a right triangle or a right angle. What do we call angles that are less than 90 degrees? What do we call angles that are less than 90 degrees? We call them acute angles. So it is an acute angle. Finally, example 5, our last one. An angle that measures exactly 90 degrees. Is an angle that measures exactly 90 degrees an acute angle? No, acute angles have to be less than 90 degrees. So we know it's not that. An obtuse. Obtuse angles have to be greater than 90 degrees. It cannot be exactly 90 degrees. So we know that that one's out. What about a straight angle? Nope, we also know it's not a straight angle because straight angles have to be exactly 180 degrees. So what do we call angles that are exactly 90 degrees? We call them right angles. Right. So exactly 90 degrees. All right, my friends, that's going to end our lesson for today. What I want you guys to do is I want you guys to please go into Google Classroom. There's a form that you'll be completing. And then tomorrow, you will be probably working on some ALEKS. Same thing for Thursday. And then Friday, you get the choice between ALEKS and Prodigy. All right, kiddos, I hope you guys have a wonderful day. Remember, I'm always available via Google Classrooms if you have any questions. Miss you guys.